Okay, I wasn't sure if I should do collisions first or smoother movement first. I'll go with smoother movement, just so that you know a way to handle it. No, actually I'll go with collisions. Okay, let's do collisions. So we're gonna make a script and call it. I could just give you the script I use, and it's gonna be basically equivalent. But I'd rather teach you how it works because it will help you learn programming more. So I'd like you to really understand how it works, and you're gonna learn a lot if you follow through with this collision thing. But otherwise, maybe I'll keep this video separate, and you could just grab the script and add it to your thing, basically. Okay, so for collisions, let's call it SER prevent collisions X. Okay, arg xval. No, actually, I'll just call it movement. Okay, so this again is going to show up at the bottom of the screen to tell you what the value is supposed to pass in. So I'll show you what this means. Okay, so here it shows up. So that's what it means. It's to help you remember what this is for. Okay, so we'll need a collision object, right? So let's create a new object solid, and we'll give it a basic sprite. SPR solid. Make it dark purple can work. Oops. You can double click the color to change the saturation. So this is going to be considered a solid. I hope that my computer basically overheating, I guess, doesn't make too much noise. So object solid, change sprite solid. Okay, so when we go in the room, here's how it's gonna work. First of all, the top right, you can change the grid size if you click the little arrow there. So I make it 16 by 16 simply because it's what I used for the player. Then click the object. You can either drag it, or you can just click once and press Alt to drop the object in the room. So okay, so I'm gonna make a wall here, and yeah, I'm just placing a bunch of walls for testing. So let's say I start the game right now. I'll go through the walls. So yeah, I passed through them. So that's not good. One way, I'll show you the bad way to do it, just because maybe you'll find it's enough. If place meeting x plus movement y object solid basically do nothing else x plus equals movement. This would actually be decent already. So I'll show you what the result will be. But it's not perfect, but it would be decent. So I actually called it prevent condition. I should probably call it move X, but I'll keep the name like that for now. No, actually, I'll call it move X. Make a copy. CR move X. So that's going to be the move X script. And for the player, I'll replace this with okay. See here, x equals x plus blah blah blah. Instead of doing that, I'll do var move x equals to this. So what this means is, instead of immediately changing the x value, immediately moving, instead I calculate the length x, which I talked about in the other video. Yeah, I calculate it and I keep it in mind. That's what it means. And then what am I going to do? I'm going to do ser move x, and this should make us collide with walls when we move left and right, if I didn't screw up. Yep, it's working. So, but it's not perfect again. If I don't know if you can see it here. Yeah, okay, sometimes I can't hug the wall immediately. Okay, so I stopped here and I can't actually touch the wall. I don't know if you see that. That's because I'm moving in increments of 4 pixels. So I won't necessarily be able to touch the wall depending on where I put it. So it's not perfect. So I guess I'll be teaching a lot of programming, so I'll show you alternatives and some solutions you can do. I'll just make sure this is recording. Yeah, okay. Instead of doing x plus equals movement, yeah, I guess I have a lot of things to teach there. Okay, here's what a while loop does. Okay, this right here, first of all, don't do that. The game will crash. This means as long as this thing is true, x, oh sorry, this is equivalent to x plus plus. These two are the same thing. They're exactly the same thing. And this is also means the same thing. But you don't need to remember that for now. That's not what's important. Okay, so as long as true is true, x equals x plus 1. In other words, as long as this variable right here is true, add 1 to x. So the player would move right forever, but that also happens in 1 frame. So this doesn't happen 30 times per second or 60 times per second. This happens forever in 1 single frame. So basically, your game will crash if you do this. So don't do that. But what you can do is, while okay, let's find a good movement variable name. Oh, I'm not in the right script. 1 second, I need to go in the prevent condition. No, I'm in the right script. Okay. Or max distance traveled equals 0, and var distance to travel equals argument 0. Okay, so the current distance traveled is 0, and the distance to travel is argument 0. So what do? While place meeting x, y, um, x plus 1 time, yeah, I have to explain a lot of things, times sine distance to travel. Yeah, that's a lot of things to explain. I'll write it, then I'll explain it. Solid. Okay. And I didn't explain place meeting before, so I need to explain that too. What place meeting does, it's a function that takes in the x coordinate of the instance or object calling it. So right now this is a player. The player calls place meeting. States the x and y, so the position where the player is, x and y, and which object it should check collisions with. Right now we want to check if we're hitting any wall, right? But we don't actually want to know if right now we're hitting a wall. If we're already in a wall, that's not useful. We want to know if we are about to hit a wall so that we can avoid it, right? So instead of doing, are we meeting a wall right now? Oops, I meant object solid. Are we hitting a solid right now? That's not useful. If we're in the wall, it's too late. So what we want to know is, are we gonna hit a wall? So x plus distance to travel. And distance to travel can be 0, can be -1, it can be 1, it can be 4, it can be -8. So we don't know if we're moving left or right, but it doesn't matter because x plus distance to travel is where we're trying to go. Okay? So that's it. Another time, just quickly. You take the position of the player, you compare with all the other solids, the object solid in the room, and if we overlap, if we're on top of a wall, it returns true. It says that yes, we're hitting the wall. Instead of putting the current position of the player, we're putting where we want to go. So where we're trying to go. Is there a wall over there? So that's the question. So that's for place meeting. Now here's what sine does. Sine 10 would mean true. Okay? Sorry. 1. Because 10 is positive. If we were throwing in -10, it would return -1. If we put in -9900 million something, it will return -1 because it's negative. So it only returns the sign. If it's smaller than 0, -1. If it's higher than 0, it's 1. If it's 0, it's going to return 0. So it's not positive, it's not negative, it's neutral. And that's important to keep in mind because if it's 0, you're going to keep adding 0 to the position of the player. And if you keep adding 0 to the position of the player, oh no, actually it's not even a problem. Forget what I just said, okay, ignore that. But yeah, that's what sine does. So here's what this is doing, right? Remember I said that while true, this would run forever and ever. The computer would crash, basically. We can do it for fun, if you'd like. Look what happens. I can't move, nothing's happening, and my computer is starting to struggle a bit. And that's because I can't even close it. So yeah, that's what happens. Okay, I close it. So you get stuck in there because this keeps repeating over and over again. Now if we do while test equals true, do test equals false, we'll check the condition, test is true, so you're gonna run the code that's here. What does the code say? It says set test to false. So then it checks again if test is true, and it isn't. Test is false. So it stops right there and doesn't run again. I can show you, just to show you. But that's what a while loop does. Well, that's actually pretty damn weird. I think it's because I didn't finish the movement code yet. But anyways, as you saw, it didn't freeze, or at least not supposed to freeze. It froze again, probably because I'm not finished. So as a preventive measure, if sign distance travel doesn't equal 0. So that's basically just making sure that we actually have a valid movement here. We don't have 0, we might have 1, 8, -4, but we don't have 0. I don't think there would be a glitch, but it's just in case. So okay, so that's what, so as long as the movement is not 0, as long as, exclamation point, as long as we are not colliding with an object at the next pixel in the direction that we're moving towards. So that's a lot of information in just one line. So yeah, again, as long as we're not colliding with something, that is the placemating part. As long as we're not colliding with a solid. Where are we checking for that? We're checking if we're colliding with a solid, 1 pixel either to the left or to the right. Just 1 pixel to the left or to the right. That's why it's 1 times sign. Actually, I don't even need the 1 this time sign. I can just do that. X plus sign distance to travel. So it's either going to be -1 or 1. Then if there is no collision, it's going to increase by 1. But there's a problem. There's a problem, and maybe that was the bug we were getting earlier. It's going to do this forever. As long as there's no collision to the right, it's going to go to the right. So we need to have another check in place. As long as there's no collision, and this symbol here means and, but you can use and as well. And distance traveled is smaller than distance to travel. Now there's something to keep in mind. If distance to travel is negative, there can be a problem. So here's another thing that's similar to sign, but it's not like sign. Abs. This means the absolute value of a variable or a number. So distance to travel will always be positive. It's never going to be negative. And then distance traveled, we need to add 1 to it. So here's what this is going to do. There's a lot of code. I'm not sure how I would make it simpler, because there's a lot of conditions in it basically. So you check if there's a collision at your current position plus 1. And as long as there is not, while there is no collision, and that you haven't traveled the whole distance that you're trying to travel, which our speed is 4, so it would be 4 in our case. As long as you haven't traveled 4 pixels to the right or to the left, keep trying to move 1 pixel to the right. If there's no collision, only. So let's test this out. Okay, there's a bug in my code because I went to the right. Oh, there's a very strange bug because I moved right even if I press the left button. So, and we know that this has to be the cause. Yeah, okay, here's the problem. X equals x plus 1. That's not what I'm supposed to do. I'm supposed to do plus sign distance to travel. Because if I'm trying to go left, I don't want to go right. And how do we know which direction we're going? With the sign. With the sign function. Now if I go right, it works. If I go left, does it work? Yep, it works. So now, I collide with walls if I go right or left. Just checking if the recording works well. Yeah, it does. Okay. Can I move this? Oh, I can move this. I'll put it in the center. Yeah, okay, that's better. So yeah, the collision works on the x-axis. Great. Now if we want to do this for the y-axis, we can copy and paste, but remember earlier I said when you copy things, you risk bugs. So I won't copy it. Instead, I'll just continue. But I'll change a few things to make it simpler. I'll teach you a new keyword, exit. Exit means quit this whole thing. It's a script in this case, so exit means quit the script. So instead of having a bunch of code all bundled up right here, we're going to change that. If sign is equal to 0, exit. I don't recommend having a bunch of exit statements all the way in your code, but when you have a condition that's essential to the rest of the code, if it's just one thing that's important, then yes, you can put it at the beginning and it's going to save you some trouble for later. And oh, by the way, theoretically, you don't need sign here, you could do this and it should work as well. If distance to travel equals 0, exit. Theoretically, you shouldn't get bugs, but when there's I just like to keep things the same, so here I use sign distance to travel, so I like to use sign distance to travel here as well. If you're using the same function everywhere, then you know that you're going to keep getting the same result everywhere. So I think it avoids bug in case for some reason Yo-Yo Games didn't write their sign function properly or something. So this makes sure that there's no bug. But it should be equivalent. Okay, so if we're not trying to move, ignore everything else. This is what this bit of code here means. If we're not trying to move, ignore everything else. Okay, back to the loop. So, what was I going to say about that? I'll keep it like that for now because it works well enough. So I'll just do the Y movement basically. I'll rename this to SCR move and it should work. Yeah, okay, because there's a few things to teach. So let's write this from scratch. While not place meeting, because again this avoids bug. Normally I would copy it, but honestly, if you're just beginning, you're going to have a harder time seeing mistakes you're making, so it's easier to just rewrite from scratch. Y plus sine distance to travel, object solid, and distance traveled smaller than abs distance to travel. So again, as long as where we're going to be, there's no solid, and that we haven't moved further than we can move, then keep moving. That's kind of what it means. So y equals y plus sine distance to travel, distance to travel, plus equals 1. I'm changing it up because you've seen this one a few times, and it's good to get used to the other way to write things. So what I'm going to do is duplicate this. Well, I don't have to duplicate it. I can just rename it, call it ser move. I could do this, and I could replace the script a bit, add another argument. Could call this one move x, call this one move y, and then Control F is going to be useful, but be careful with it. If you press Control F and you put in, for example, distance traveled, and you replace it for distance traveled y, traveled x, and you click replace next, you replace a bunch of distance traveled. But you have to be careful with it because you don't want to replace the wrong thing. So you can select this with the arrows, which one you're trying to replace. So now I replaced all the ones above, but not the ones below. And there's a few other ones I didn't. Yeah, okay. Wait, did I screw up? Yeah, that's what happens if you're not careful. So I'm going to revert this whole thing. Control Z. Oh, no, this is fine. Okay. This is where we were. I'm not gonna keep this in the single script. I'll make a separate script because that's what happens when you try to change things. You create more problems because you make mistakes. So I'll copy this whole thing. I'll keep it as ser move x. I'll duplicate this. This one will be ser move y. I'll remove everything that's related to x. So it's the exact same code with the exact same variable names, but it affects y instead of affecting the x position. And now, if you want this ser move, you ask for movement on the x-axis, you ask for movement on the y-axis, and then you do ser move x argument 0, because x is the first, and then you do ser move y argument 1, because y is the second argument, and then this should just work. So let's try it. Oh wait, when you copy things, then don't forget to remove what you don't need and keep what you need. This is the x-axis stuff. So by the way, you don't have to remember this by heart. I'm showing you this so that you understand how it works, because I think it will teach you a lot about programming. Even if you don't understand it fully right now, you it'll open your mind to what you can do with stuff, because it's a pretty complex line of code that allows you to do pretty complex things, right? And if you're able to understand it, you'll be able to understand a lot of things and come up with your own solutions to tough problems. But in practice, all you need is a script that works for what you need, and that's it. You don't need to write this every time like I'm doing. I'm doing it to teach you. So okay, so that's the movement script. So yeah, here basically we'll replace y equals y plus landing gear, etc. Replace this with this, so we store it in a variable like we're doing with movement x. Then we move x, then we move y, and this should work. Nope, nope, there's a problem with the code. If I press down, I teleport to the bottom. So there's a bug in my code. Let's go see what it is. So okay, so when you try to find a bug, what you have to do is read the code as if you were a computer and try to understand what it means. So this checks for collision at the next y position, depending on the sign, so the direction that you're moving, either up or down, and it checks for solid objects. That seems good so far. And you make sure that the distance traveled, I think this is the bug here. I'm incrementing distance to travel instead of incrementing the distance already traveled. So basically a typo. I put the wrong variable at the wrong place. Let's see if it works now. Seems to work. There's still the slight problem of going up and being 1 pixel away from the thing. There's no perfect solution to this. It happens whenever you don't move perfect pixels, basically. But I am surprised because it doesn't seem to happen on the other angles. So that is interesting. I have to compare with my other code to see if there's something there. But usually your player character won't have the hitbox as wide as its sprite, so that you can have the sprite go a bit through the wall. And also because if the hitbox is perfect, if your player is as big as its sprite, people will try to cut corners, try to turn around fast, and it hit the wall when they think that they shouldn't have, because it's too precise. So usually you won't have a smaller hitbox. So let's say you go in the player sprite. Usually you want it in the center. Then collision mask. So if automatic, you can put manual. Then you increase and subtract the same on both sides if it's a top-down shooter. So let's say I increase by 2 on this side, 2 from the top, and then I remove 2 here. So 13, 13.